Hey guys, today we're going to see the maximum product SubArray problem. As you can see, this is a medium problem and it's the problem number 152 on LeetCode. So given an array, integer array, nums, find the contiguous subarray within an array containing at least one number which is the largest product. Okay, so let's take this example. So 2, 3, minus 2 and 4. So the largest product is going to be 6, which is got by multiplication of 2 and 3. So if you consider 3 and minus 2, it's going to be minus 6, which is not greater than 6. And if you consider minus 2 and 4, it is minus 8, which is not greater than 6. Right? So 2, 3 can be the only subarray which gives us the largest product. Let's take the other example. Minus 2, 0, and minus 1. As you can see, minus 2 into 0 is 0. And 0 into minus 1, if you consider this subarray, it is going to be 0 again. And you cannot take minus 2 and minus 1 to get 2 because that is not a subarray. So this problem sounds quite similar to Kidaine's algorithm, mainly because of the fact that it says like you have to find the contiguous subarray within an array. And the only difference is we have to find the largest product. And there we'll be finding the largest sum. So the approach is quite similar to that. What we're going to do is we're just going to maintain two variables, max and min. So initially we're going to set the max and min to denote the first element. And whenever we encounter a negative value, let's say minus 2, we swap the min and max. This is because any number, if you multiply it with minus, it becomes less, right? So that's why whenever we encounter a negative value, max will become min and min will become max. So let's quickly check how this approach is going to be and let's program it. Okay. So as I said, I'm just going to have a max product which is going to be just nums of 0. Okay. So now for and so what we're going to do is if nums, if this is equal to null, right? I'll check, or nums dot length if this is equal to 0, this means the max product can be actually only 0, right? So else what we're going to do is index 1, because we've taken max products this, and we'll also have a max which is also denoting nums of 0. Okay, and we'll initialize a min which is also pointing to nums of 0. Okay, so now index is less than nums dot length index plus plus. Now if nums of this index, if this is less than 0, if this is a negative number, then we're going to swap min and max. Okay, I'll illustrate with this example so that it's clear. So for now, please follow. And temp equals a normal swapping process. So temp is equal to max, then max is equal to min, and then min is equal to temp. Okay, so we've done the swapping. If not, we'll just calculate. We were encountering the positive number, so we need not worry. So max is actually nothing but math dot max of, same like the Kidaine's algorithm there, plus we'll do plus, and here we do product. So what we're going to do is whatever max was there, we're going to multiply it with the current number, nums of index, and I'm just going to say nums of index. And for min, you're going to do the same thing except for calculating the min. Okay. So min into nums of index. So for the first encountering element, this is going to be just the same as max and nums of index. And this is minimum. Okay, so what you're going to do is once you do this, Max product is nothing but math.max of whatever max product that we have calculated so far and max. So once this for loop is over, we can safely return the max product, which will be containing the max product of the contiguous SubArray, which is largest product. So for this example, the first example, we've got 2, 3, minus 2, and 4. So initially max product, I'm going to denote it by max p, it is going to be 2, and max is also equal to 2, and then min is also equal to 2. Now the first element that we're going to encounter, right, we're going to start the loop from 1. So as 3, so 3 is a positive number, so we will not encounter this block, and so we'll just do the max calculation. So max is nothing but max of mathematical.max of whatever max we had into the current number, which is 2 into 3 comma 3, which is going to be 6. Okay, and then min is going to be min of the same thing, because min is 2 again, and to the current element comma 3, so out of which it is going to be 3. And then our max product is going to be nothing but max of the previous max product, which is actually 2, and the current max, which is actually 6. So this is going to give me 6. So 6 is the max product. Now 3 has been processed. Now we're going to process minus 2. So minus 2 is actually a number which is less than 0. At this point of time, we're going to swap min and max. So what we're going to do is max is equal to min, which is 3, and then min is equal to 6. Okay, and what we're going to do is we're going to do the same thing, right? Max is equal to max of the current max 3 into minus 2 comma minus 2. So minus 6 comma minus 2, which is greater, minus 2 is greater, and min, we're going to do min is actually 6 into minus 2 comma minus 2, out of which is greater and which is smaller, minus 12 is smaller. Okay, as you can see, so far we had got 2 into 3 6, right, and 6 was the maximum one. And why are we swapping? Because when you swap the bigger number, when you multiply the bigger number with the negative number, that becomes the smaller number. Okay, so that's why we're swapping min and max when we're encountering a negative number. And then we'll calculate maximum product, which is nothing but max of previous maximum product, which was 6, and the current maximum, which is minus 2, which is still going to return me 6. So we have processed minus 2, then we have got 4. Okay, we've got 4. So 4 is actually a number which is positive, so we directly can ignore this block because it's not less than 0, and we'll directly come to max, so which is nothing but max of the current max into this particular number. So the current max is actually minus 2, so minus 2 into 4 comma 4, so which is actually 4, right? And min is going to be min of the current min, which is minus 12 into 4 comma 4, so out of so the min is going to be minus 48. Yeah, and so max product, right, maximum product is going to be the maximum of the current maximum product, which is actually 6 so far, and the current maximum which is 4, so still it is going to be 6. So that's so we have exhausted the loop, right? We've looked at all elements in the loop, and finally we can return 6. Okay, hope it's clear, and let's quickly run this code. It's accepted. Let's submit this code. Yes, it is a successful submission. As you can see, we are iterating over the array only once, so the complexity is going to be of 1. a recap. We're just going to initialize the first element as a max product, and we're just going to initialize the first element as a max and min. And for every other element in the array, while iterating over it, if you're encountering a negative number, we swap the min and max, because a bigger number multiplied with a negative will become a smaller number, whereas a smaller number multiplied with a negative value will still be greater than the larger number multiplied with a negative value. Okay, based on that principle, we will be swapping whenever we're encountering a number which is less than 0 or negative. And then max is nothing but, this approach is basically similar to Kidane's, right? So here it is multiplication. That's why we're, whatever max is that we've got so far, we're multiplying it with nums of index, and then we are considering nums of index as well. So this will calculate the max, the current max, and this will calculate min, calculates the current min. And then maximum product will be whatever whatever is the maximum between the max product so far and the current max calculated maximum. Okay, and finally we are returning the max product. Okay, so that's it guys, hope you like it. Bye.